This is a compound interest and growth formula, and I think you've seen this before. It is amount is equal to PERT, okay, PERT, and P stands for the principal, meaning the money you put in at the beginning. The A stands for the amount of money that you will get in return, and R stands for the rate of interest. So T stands for the time that you leave that in the bank. Now, compounded continuously, and that's what the word is. So this is a compound continuously. Okay, when it's compound continuously, we use the PERT, P-E-R-T, like the shampoo. Okay, the same formula where you have A is equal to P-E-R-T changes to Y is equal to C-E-K-T. There's no difference, we just change the letters. So when we're not talking about money, we use this formula, and when we're talking about money, we use this formula. And these two formulas are exactly the same. This is the interest rate, that's why we use R. This is known as the growth constant, K. Okay? Alright, let's go ahead and do a few problems. I would derive this formula for you, which is pretty clever, but I don't think you're interested in it. So let's go ahead and just jump in and finish this. Otherwise, this tape will be, or the video will be about a half hour, 45 minutes long. Alright, number one. This is section 43. It says, Juanita started a savings account with $2,000. Okay, $2,000. That's the starting point. That is going to be called the principal. Okay, and for her birthday, the bank pays rate of 4% interest, 4%, and that is your rate. But you can't write 4%. You have to convert that in decimal. That'll be 0.04. Okay. And the interest is compounded continuously. Find the balance at the end of the 4 years. So at the end of 4 years is T is equal to 4. So A is equal to P-E-R-T. So the amount we're going to have at the end of 4 years is going to be $200, okay, times E to the 0.04 times time, which is 4. Okay. So we just go to our handy dandy calculator, and we have to find what is that value right there. Okay, so this, if you clean it up a little bit, let's do that real quick. Okay, that is E to the 0.16. So we're going to find E and raise that to the 0.16, and I have it in my calculator. See, 0.16. Okay, and that's that. So this, now I'm going to multiply that by 200. So when you multiply that by 200, okay, and you're going to get $234.70. Okay, that is compounded, okay, continuously. Back that up a little bit, clean it up. So this is the dollars, and we always round to cents. Okay, so 2 places. All right, that was easy. So let's go to section 44, where things get a little bit more complicated. Section 44. This is section 44, and number 1. Okay, number 1 says Johnson's bought a condominium for $63,000. So that is the starting point, so we'll call that C is equal to $63,000. Assuming that its value appreciated 8% a year, so the rate is 8%. We'll convert that to 0.08, okay, which is same thing as 8%. How much will the economy be worth in 5 years? Okay, So we want to know how much will it be worth when t is equal to 5. Same thing. Okay, we're not. So we can still use the PERT formula. Amount is equal to, instead of calling, let's go ahead and call that principal. Okay. So that's $63,000. Okay. So $63,000. Okay, E to the 0.08 times 5. That's my time. So when you simplify this, this would be $63,000 times E to the power of 0.4. So go to E, okay, and raise that to the 0.4. And then we're going to multiply that by $63,000. And there it is. It turns out to be $93,984.96. That's how much the condominium will be worth. Okay, so it's still easy. Okay, let's go to the next problem. Because a piece of office equipment is worth $25,000, so that means we pay $25,000. That's how much that's worth. Okay, and it says it depreciates at the rate of 10%. So the rate is, depreciate means it goes down by 10%, doesn't go up. So that will be negative 10%, which is really negative 0.1. And then they want to know how many years will it take to be worth $5,000. The amount is going to be worth at the end is going to be $5,000. So we're going to use the formula PERT. So A is equal to P-E-R-T. Oops. Let's back that up. R-T. Okay, so we know A to be 5,000. That's what we're going to end up with. P is what we start out with, which is 25,000. And then E to the negative 0.1 t, and we're trying to find out what time. Okay, we're trying to find time. How long does it take to get to 5,000? Okay, so we're going to divide by 25,000. So the zeros are going to cancel out the zeros, and 5 divided by 25 is going to be 1/5 is equal to E to the negative 0.1 t. And then to solve for t, which is in the exponent, we'll have to ln both sides. So we're going to go ln of 1/5 is equal to negative 0.1 t times ln of e. And we should know ln of e is 1. So therefore, right, t is equal to ln of 1/5 divided by negative 0.1. So we're going to go ln of 5, ln of 1/5, 1 divided by 5, and then we're going to divide that by negative 0.1, okay, and there it is. My t turns out to be 16.094 years. Okay, so it takes you about 16 years to go down to $5,000. All right, so let's move on. There's two more, and then we can stop right there. So this is, we're still in section 44. This is number 4. It says a substance decomposes radioactively. Its half-life is 32 years. Okay, so 32 years is the half-life. Okay, find the decay constant. So they want me to find the decay constant, which is, we'll call that K. Right, so when we're talking about money, we use PERT. When we're talking about everything else, we're going to use same formula. The only thing is we're going to change some letters. So Y is equal to C-E-K-T. Okay, so instead of PERT, this is the same as PERT. Okay, A is equal to P-E-R-T. All right, let's plug in everything that we know. Okay, we don't know how much we started with, so we'll just call that C. And then E, and we're trying to find K, okay, and it says, you know, 32 years is the half-life. So at 32, okay, K, you're going to have not this much, you're going to have half as much as that. So that means 1/2 of C. So that's what the formula becomes. Okay, and we're looking for this K, which is known as the growth constant or decay constant in this particular situation. Alright, so when we divide both sides by C, you're going to get e to the 32k is equal to 1/2 because the c's are going to cancel each other out. So the c's are going to cancel each other out. Okay. And then we're going to ln both sides. So when you ln the right side, you're going to get ln of 1/2. Of course, when you ln the left side, you're going to get 32k. Okay, 32k. Right. So we're going to go ahead and solve for k. So k is equal to ln of 1/2 over 32. So let's go back here. And so it's this. And move it over here. Ln of 1/2. And then divide that by 32. Okay, and we should get our growth constant. And that's approximately negative 0.0217. That is the growth constant. So my formula looks like this: y is equal to c e to the negative 0.0217 t. Okay, that is the formula for this particular problem. But we're only asked to find k, so you're done when you get to there. Alright, one last one. So let's go to number 9. Okay, rabbits were first brought to Australia in the 1800s. They had no natural enemies, so their numbers increased rapidly. Assume that 60,000 rabbits, and there were 60,000 rabbits in 1865. Okay, and then there were 2,400,000 rabbits in 1867. So in 2 years, okay, it went from 60,000 to 2,400,000. Assuming the rabbits grow exponentially, how many rabbits would you expect in 1870? So we want to find out how many rabbits there are in 1870. Okay. All right. So we're going to start here, but we got to find out how many years that is from there. This is 67 now. 62. So in 1867, so that's 2 years. So what we know is this: if you use y is equal to EKT, C times EKT, we know this, which is 2,400,000, and we know C, which is 60,000, and then that's E to the K, which we don't know, we'd like to find, but we do know what T is. T is 2 years. Okay, so that's 2K. Alright, so let's go ahead and solve for K, and then we can plug it into our equation. So let's cancel out all the zeros. So 1, 2, 3, 4, cancel out 1, 2, 3, 4. So what I have is 240 divided by 6 is equal to e to the 2k. So 240 divided by 6, so that is going to give us 40 is equal to e to the 2k. Okay, so we're going to take ln of both sides. Ln of 40 is equal to 2k, because when you take it on the right side, e is going to disappear for us. So my k is equal to ln of 40 over 2. And you want to leave it like that because you don't want to convert them to decimal yet. So my formula now becomes y is equal to 60,000 e to the ln of 40 over 2, that's my k, times t. Okay, so we start out with 60,000, that's the initial amount. Okay, and we want to know how much will we have in 1870. So 65 to 70 is going to be 5 years. So this is my time. So I can just plug that in right now. Okay, so this becomes y is equal to 60,000. Okay, e to the ln of 40 over 2 times 5. Alright, let's calculate that. Okay, the graphing calculator is pretty easy. So let's go to punch it ln, 60,000, and then we'll go to time, so we're going to go e, and then we'll raise that to ln, okay, ln of 40, 40, and we're going to divide that by 2, okay, and then I need to put another set of parentheses, so parentheses, and I need to multiply that by I, and then close my final parentheses. Alright, here it is. Okay, if you look up there, it's written just the way I wrote this right there. So it tells me the amount of population is going to be 607157310, and I have to ignore the decimal at the end because I'm not going to have a 0.75 rabbit. Okay, so put some commas here, and we'll be done. There it is. That's how many rabbits will we have in 1870. Okay, there's that.